Time is not passing at the same rate for everyone on Earth right now. Not approximately. Not as a metaphor. Right now, at this exact moment, time is moving faster for someone standing on a mountaintop than for someone standing at sea level. The difference is measurable. The GPS satellites orbiting Earth must correct for it constantly. Without the correction, navigation would drift by kilometers per day. Einstein called this gravitational time dilation. He predicted it in 1915. We confirmed it with atomic clocks on airplanes in 1971. Your head ages faster than your feet, measurably, literally, every day. Now let's talk about speed. The faster you move through space, the slower you move through time. This is not a theory. It is a measured, confirmed, tested fact. Astronauts aboard the International Space Station age slightly slower than people on Earth, not because of anything biological, because they are moving faster through space, and time itself runs slower for them. When Scott Kelly returned from a year on the ISS, he was approximately 5 milliseconds younger than his identical twin brother who had stayed on Earth. 5 milliseconds. After a year. The difference is small because the speed is small relative to light. At the speed of light, if such a thing were possible, time would stop entirely. You would arrive at your destination having aged nothing. The universe outside would have aged by however long the journey took. You would step off the ship into the future. Now let's talk about what time actually is. Newton believed time was absolute. A river flowing at the same rate everywhere, independent of anything happening in it. A universal clock, ticking the same for everyone. Newton was wrong. Einstein showed that time and space are not separate things. They are one thing, spacetime. And spacetime is not a fixed background. It bends, it curves, it stretches. Massive objects warp spacetime around them, and what we experience as gravity is not a force, but the shape of that warped spacetime. Time runs slower near massive objects. Near a black hole, where spacetime is warped to an extreme, the effect becomes profound. An observer hovering near the event horizon of a black hole would experience time passing normally for themselves. But looking outward, they would watch the universe fast forward. Stars would be born and die in seconds. Galaxies would evolve in minutes. Billions of years could pass outside while hours passed inside. Now let's talk about the past, the present, and the future. In Newtonian physics, there is a universal now, a single moment that is simultaneously present everywhere in the universe. Something happens on a distant star, and there is a fact about whether it happened before, after, or at the same time as something happening here. In Einstein's physics, there is no universal now. Simultaneity is relative. Whether two events happen at the same time depends on your frame of reference. Two observers moving relative to each other will disagree about the order of events. Both will be correct. There is no fact of the matter about which came first. The present moment is not a universal property of the universe. It is a local experience. Your now and my now are not the same now. Now let's talk about what this means for the arrow of time. The laws of physics, almost all of them, work equally well forwards and backwards. Run a video of two billiard balls colliding, and it looks the same in reverse. The physics doesn't care about direction, and yet time has a direction. We remember the past, we don't remember the future. Eggs break and don't unbreak. Things burn and don't unburn. The direction of time is real, irreversible, undeniable, and yet the fundamental laws describe a universe with no preferred direction. Why time goes forward is one of the deepest unsolved problems in physics. The answer may involve entropy, the tendency of systems to move from ordered to disordered states. The universe started in an extraordinarily ordered state at the Big Bang. It has been getting more disordered ever since. The direction of increasing disorder is the direction of time. Time exists because the Big Bang was very, very tidy, and the universe has been making a mess ever since. And finally, the one that dissolves everything. The block universe theory, supported by Einstein's equations and taken seriously by a significant number of physicists, proposes that past, present, and future all exist simultaneously. That the universe is a four-dimensional block in which all moments, every moment that has ever existed, every moment that will ever exist, are equally real and equally present. In this model, there is no flow of time. There is only the block. What we experience as the passage of time is consciousness moving through the block, like a reader moving through a book. The pages that have been read still exist. The pages not yet read already exist. The reader moves. The book does not. In this model, the moment you were born still exists. Every moment of your life still exists. Everything that will happen to you already exists. The present moment is not special. It is just where you are, right now.